All right, everybody, welcome to the December meetup, the December Leptos meetup. My name is Luke, as always, and I'm super stoked to have everybody here joining us this month for the what is going to be the second to last meetup for the year. We've actually kind of behind the scenes been planning a potential sort of holiday, sort of end of year Leptos meetup, which may be in a week, 2 weeks, something like that, probably before everyone goes out on holiday breaks, and then we would pick back up at the end of January. But we will announce that in the Discord server when we know more. And yeah, to that end, so keep an eye on the Discord server. It should be in the description. If not, I'll add that in here momentarily into the description. So we have an awesome meetup this month. We've got a few special people with us. So this month it's myself, it's Ben. We've got Danielle's joining us. She's been working on some amazing things in the component library front with for Leptos. And we've got Enzo and we've got Mikkel here, who are going to be discussing Spin, which is an well, I'll let them describe it. I'm a total fanboy of Spin. It is making bringing Rust to the web so much easier. Not just Rust, but any language with WebAssembly target. So to that end, I will bring Ben up onto the stage. And Ben, I think you have some announcements, and then we'll go to Danielle. How are you, Ben? I think you are muted. I'll unmute you.
I'm doing great. I think technically this is the November meetup, but
is it?
Well, we didn't do one in November, and this was supposed to kind of be yesterday typically, so going with yes.
Actually, I think you're right. I think you're maybe, I don't know. They've been like kind of like falling at the end of the month and beginning, and now I don't even remember if we do it in the first at the month and the last one of the month. I'm not sure.
Yeah, well, either way, I'm very excited about the changes in Leptos recently. For those of you who've been following us, we've just released 0.7 proper, which is like a complete rewrite of the back end of Leptos. The reactive system was refined and improved. And there's so many nice changes, both for us as developers and for you as users, right? We've got tons of things to play with. You can now use futures in your resources. We've got improved performance and lower bundle size. We've got, it's almost too many things to list, really. It's just big changes. So I'm very excited about that. Huge props to Greg, who I'm hoping will come on later so we can tell him in person, and the team and our testers and our community members, all the people that have been keeping up with us and filing bugs. It's we can't do it without you, definitely. That is that is it. Check it out. Let us know which things have slipped through to the 0.7 release. In other news, we're looking at reworking how server functions return errors and custom errors in a quick 0.8 release. It shouldn't affect most of you unless you're doing custom things, but I'm expecting that to come out around the end of December. January-ish, we'll have an RC up for people to play with soon. So keep an eye out on that as well. Big changes around the holiday season for sure. Hopefully not too fast. Besides that, in personal news, I'm about to start a new job with IDverse. IDverse does ID verification, but they also use Leptos in production. And another thing they've done is they've kindly agreed to pay for part-time open source time. So I'll actually be the first somewhat paid person to work on Leptos. So I'm very excited about that as well. It's been a good year for us, I think.
Dude, that is awesome. I didn't know about that, but first of all, congratulations. That's awesome.
Thank you.
And that's super amazing that we've got some. I mean, you and Greg have both been putting in so much work, so nobody deserves it more than you guys. So that's super awesome.
I'd say we need to get Greg set up, but he seems pretty happy with his day job, so that might be a harder sell.
Yeah.
But yeah, huge thanks to Raphael, who's my new manager, I think. I'm not quite sure about the org roles yet. I start tomorrow. So, and any of the rest of the team that's here, thanks for coming. All right. So that is announcements, I think, the big ones anyway, for Leptos proper. Let's transition over to Enzo, and we'll talk a little bit about some of the other changes that are coming.
I
So
think
Enzo, go ahead.
I think we're going to go to Danielle first. We're going to go to
Oh, sorry.
Danielle,
We can go to
and
Danielle
then we were
first.
going to,
Sure.
yeah, and then we were going to jump over to, yeah. So Danielle, I'll bring you up, and okay, all right. So you wanted to discuss with us about some work you've been doing on the component library front, yeah?
Yeah, that's correct. Thanks for having me.
Absolutely, and welcome.
If I can share my presentation.
Sure thing. If you share it, then I'll put it up on the screen.
Yeah,
Okay.
should hopefully be sharing.
Yep.
Yeah, all right. So I'm here to talk about Rust for Web. This is like a collection of libraries that I'm working on over the past few months that are related to doing web UI, specifically for Leptos, but also some other Rust web frameworks. So I'm first going to talk a little bit about how it all started. In the beginning of the year, I was looking into building a web app and in Rust, and I was also very interested in doing the same thing for the front end. I also wanted to use Rust there. That's how I ended up finding Leptos. But the thing was, I couldn't really find a good UI framework, something comparable to, for example, this Jetson UI, which is a very popular React library. I was really like kind of missing something like that. There were a few UI libraries out there, but they weren't really that extensive. So that's when I decided to start looking into maybe porting this to Leptos. Like, how hard could it really be to get this to Leptos? And that's kind of where I started off. So this is what I wanted to build, and I started to look into it, and it was built on top of another library called Radix Primitives. These are unstyled components. So it basically means that they provide things like checkboxes, drop-downs, dialogues, all those kinds of sort of essential components, but they do it in a very, like they've spent a lot of time into getting them compatible with web standards, and more specifically, like the accessibility standards, so that all the ARIA rules and all that kind of thing is implemented properly. But there are also various components that use floating elements. So for that, they use another library called Floating UI. So we're going down the rabbit hole. So yeah, that's sort of essentially where I started. Porting, Floating UI, and then continuing up the tree. But there's a bit more. They also use icons from Lucid, and they have their own styled library, Radix Themes. Some company reached out to me, was interested in doing working on that. That's something I've also been working on. They have their own icons. And in addition to that, I was interested in doing testing, similar to the testing library that is available in React. So this is sort of the entire chart of all the libraries and how they're connected. And I was sort of looking at this, and I simply started as a bottom before thinking about any of this. I was just like, okay, would it be possible to get Floating UI ported to Leptos? That was sort of my initial question. That's where I started. So, but in the end, we would like all of this to work in Rust. And yeah, I've been working on this for the past few months, and today I'm going to show you some of the work on these libraries and some of the things that are actually already working in Rust, and some of the things that are a bit more in progress. So the first one is Floating UI. This is more of a library that other libraries use, because usually you don't implement floating elements yourself, but the library already does it for you. For example, dropdowns, tooltips, dialogues, all that kind of thing. And these are some of the examples that they provide, but these are fully written in Rust. So everything you see on the screen here is running in Leptos. Still 0.6, but it is Leptos. So for example, they have positioning, so automatically aligning a floating element to a reference. They can do, like, based on your screen, flip it to another direction, that kind of thing. And also something more simple, more useful, like a tooltip. That's very common in a lot of web UIs. And this looks, let's see, roughly like this. don't pay attention too much to the code, but this is a very quick example. Essentially, floating UI provides a hook down here, which you can pass a reference and a floating element with some options. So for example, they have the top placement here, but you can also provide middleware, like offset or flips or the arrow. And floating UI will basically calculate all of this for you. And this is like the only thing you really need to deal with. And it will give you floating styles, which you can then apply to your elements. And this kind of code is like the underlying thing for most of the floating elements in Radix. So that would be the next thing. The Radix primitives. These components are unstyled, but they do provide styled examples. So that's what you're seeing here. Again, this is all running in Leptos. So for example, avatars or checkboxes or toggles, that kind of thing, a progress bar. All of this is available at the moment, but they also have some more complex stuff like drop-downs and dialogues, which are still work in progress. And this looks roughly like this in Rust code. They provide separate packages for each of these, so you can like import only the stuff you need. And yeah, the syntax is very simple to use, especially if you're already familiar with this from the React side of things. You will see that like the components work essentially the same as you would expect in React, but this is written in Leptos. Yeah, and they also provide something more complex. So this is a select, for example. They provide all these parts that you need to piece together. So you could, of course, if you're actually building an app, maybe abstract over this, or that's what their own styled library already does a bit, because it would be a bit cumbersome to write it every time. But let's say you were to provide like some items as props and then abstract away all of this, it would be very usable. And it also handles things like scroll. Yeah, essentially all this. This is still a bit more work in progress, but this is what it roughly looks like now, but it's not entirely functional yet. And then there is the themes. So this is their style library of the unstyled components we recently saw. Yeah, that looks roughly like this. They provide a single library that you can use, and you can simply import various components from there. They provide abstractions over Flagbox and Grid, but also the components you saw like avatars and like for example cards and text. So this is more of a fully featured UI library that you would expect to use in your application, especially if you don't want to deal with styling. This provides most of that out of the box. And this is what I really wanted to make Shetson UI. This is built on top of the Radix primitives as well. And it definitely has a very particular style, which is also why it's pretty popular right now. And it looks very similar to the Radix themes, but it's more based on Tailwind. So it doesn't provide a lot of styling out of the box, but they provide most of that with Tailwind. So these components you would need to copy over to your own project. That's how their framework works. Now you can add additional classes to make sure that it lines up properly. So in this example, we have a card with 2 fields and simple inputs, and a select field and some buttons to like click it. But everything like variants works with Rust enums. And yeah, this is essentially how it will, what it will look like in the end. And one of the last things that I mentioned is I would also like to have some sort of testing library, because this is what I'm used to from the React world, or more, yeah, the TypeScript world in general, that you can have like query by ID or get by ID, this kind of thing. And I would also like to have that for Leptos or for other Rust frameworks. And that would look something roughly like this. This is still a bit work in progress. But as you can see here, if you were to render a very simple HTML thing, you can query it by, for example, the text or by the placeholder, and then do assertions on it. This kind of thing is very useful when you're building out more complex web frameworks, that you can actually verify with code that your components behave as you would expect it. And it's a lot easier when you have these utility methods than doing it out of the box. Yeah, so that's a very quick overview of all the things that the Rust for Web projects currently provide. It's available for Leptos, and I'm also doing a lot of work in U because the company was interested in doing it in U as well. So I'm working on 2 frameworks at the same time. So if you're more interested in U, even though you're at the Leptos meetup, you could also use that. And these are sort of all the socials. The website on top there will also have them linked. That's the easier one to type out. Yeah, so that's essentially it. Are there any questions?
That
Oh,
is
boy.
really awesome.
I
Go
could
ahead.
not be more excited. I guess I say that a lot now, but Shad CDN UI, you know, is one of those things. It'd be great to have in Leptos. I guess my question would be like, what do you think the status of it is, right? Could I go out and start using your libraries crates now, or do you think it needs a little more refinement?
Yeah, it's like the primitives are definitely ready to use. The only caveat is that they're currently still on 0.6. I'm working on the 0.7 update, so yeah, it's kind of not really ready to use if you're on 0.7. And the ChatCN UI, that is like mostly not yet really ready for Leptos. It is for you at the moment. So porting over like between the 2 libraries is relatively simple. So I'm hoping to get Leptos in a similar state pretty soon.
Oh, you didn't say, so you've done it for EU as well? Have you done it for any of the other Rust web frameworks?
No, just Leptos and you, and it's already so much work. Like all of these JavaScript components are already like thousands of lines.
Right.
Yeah, and then working out to Rust, it expands into even more lines because it's more verbose and more typing and all that kind of thing.
Mm-hmm. I don't know if anyone's interested in helping, but are you looking for contributors as well? Assistance?
Yes, definitely. If you're interested in helping out, join the Discord or look at the open issues. There are issues for essentially any components. Or if you're interested in working on anything, just like leave a comment on one of the issues, and then I will know that you want to work on that, so that we don't have like conflicting implementations, that kind of thing.
Very
Daniel,
cool.
can you send me something? I know that you had a few you had the socials for Rust for Web on the screen a minute ago. Is that where you would want people to contact you? Just through rustforweb.org?
Yeah, that definitely works.
Okay, cool. I'm going to post that in the chat, so anybody watching can go find it there. That is super awesome. Let me ask you, did you do this by yourself, or were there other people that have helped you up until now?
No, up until now, this has all been my own, a lot of work over the past few months, essentially.
Wow, that's really impressive. That's really great.
Oh, for sure. I mean, I'm excited about that. I mean, I'd love to have more CSS component libraries in Leptos. You know, we've got a couple, and I'd love to have more. So, props.
Thanks.
Absolutely. Well, yeah, we have some people who are excited about the work, but it doesn't look like we have any questions. So I would wrap up here, and we would then move on, if that's all right with you, unless there's anything else you had, Danielle?
No, that's it for me.
Okay,
thanks for having
awesome.
me.
Thanks
Absolutely.
again
Thank
for
you
coming
so much
on.
for joining. Yeah, and oh, cool. Somebody says they're already using it for their 0.6 Leptos color crate, and it's working as expected.
Oh, cool. I hadn't seen that.
Yeah.
Nice.
Yeah. So, awesome. Okay, great. Thank you so much, Danielle. And we will move on then. And Ben, I will let you intro.
All right. So for those of you who've been following us, we've had a spin integration for a while, which we'll be talking about a lot more after this speaker. And Enzo came out of the blue and kind of created his own version of the Leptos spin integration based on the the WASI standards, some of the stuff that's come out most recently in part 2. And kind of in the 0.7 release process, it's become the base for both the new Spin integration and for a WASM Cloud integration. So huge props to Enzo for doing that. I didn't really have a ton of involvement in it until the end. So I'd love to talk. I'm excited to talk to him more about. I'm excited to talk to him more about it. So I'll let him come on here. Hi, Enzo.
Hi, everyone.
So, what made you write Leptos wasi?
Basically, I've been following the WebAssembly ecosystem since a while, and for those of you who know a bit about WebAssembly, should I go directly into the presentation, or
Sure, if you'd like to.
Yeah, I can explain it with my screen. I think it will be easier. All right, so basically, for those of you who don't really know WebAssembly, that's a new instruction format that runs inside of a virtual machine, but essentially that's really efficient and close to native speed. And that's
so
really...
would you mind zooming in a little bit? I can already see the comments coming into the live chat. So.
Yeah.
There, awesome. Thank you so much.
But basically, yeah, WebAssembly has been started to be popular in the browser because, as you know, Leptos actually compiled down the front end to a WebAssembly module. And basically, there started to be some, we started to see that this sandbox environment could be used outside of the browser. And for example, you could run WebAssembly modules on the embedded system, in the cloud, let's say it in this way, on the serverless platform. So people started to build the first WASI version, which is really close to POSIX. So if you are a Linux user and you build system, you really interacted with POSIX a lot. And most of what you use actually run POSIX. And then there was this second version of WASI. This is where I've been working. That is a set of API, a modular API that you can add or not add in the sandbox. So your WebAssembly module can consume them. So basically, everything is defined as using an ideal that's called width. Of course, my dog needs to bark now. Great. So if you know protobuf, width is the same but for WebAssembly. And basically that defines the system API that your component your module will be able to use outside of the browser. So for example, this one is what I've been using. It lets your component expose a handle function that will be called by the host whenever HTTP requests come in. And that's my main hook point to make the Leptos server run.
Nice.
Basically, that's what I've been doing. So
this is a feature of WASI Preview 2, right? WASI P2?
Exactly, yeah.
Okay.
There is a lot of different... so basically, they have a repository for every different interface, because there is more than one. And they define the interface using this language. I can show you... Yeah, for example, the pullable interface defines some function. And it's either the host called the module or your module call the host. So that really create a custom API. You can create your own sandbox if you want.
Can you make it a little larger?
Yeah. Anyway, that's just an example. But yeah, basically, the host can expose those functions. This is to do I/O, asynchronous work. So the host exposes some function, and you can call it inside the module, or the other way around, basically.
Right, and you can compile any language. I know we're doing Rust here, but you can compile any language to have the same interface using WIT or this, right?
Yeah, basically, for example, if I come back to, so yeah, for now I've been using Rust indeed, but if you look at the signature of this function, the handle function, basically when I use the width generator, so to generate the binding with bindings, it turns the function into Rust native code like that. The handle is there with the same parameters. But yeah, the dream is that you can do it with every language, basically. Of course, Rust is the most supported. There start to be really a good integration with Go as well. But yeah, I've been working in Rust mainly.
Nice.
So just to give an overview how that work for people that never use WebAssembly, you have your host or your Leptos, your laptop. Leptos, always. Laptop, a server or anything. You run your WASM runtime on top of it, and you can choose these nice interface that we just saw and expose them to the module, which is called component in the wasi P2, basically. And so the crate I have been working on, which is this one, the Leptos wasi, I think I can send the link on Discord or anywhere.
Oh yeah, definitely send us a link. We'll definitely post that.
Yeah. Anyway, it's on the main Leptos organization, so you can find it pretty easily. But basically, the goal of this crate is that you can focus on your Leptos application and not do all the little integration stuff that you need to do to make it work in a WebAssembly wasi environment. So basically, it hooks into the crate, and then it deals with all the routing logic and so on. So it do static file serving. It can also serve your server function, still running inside of this wasi P2 environment. And then it does the Leptos rendering to actually render the application using response streaming, so asynchronous, the only asynchronous mode. So yeah, basically that has been my work. I will show you quickly how it looks like. So there you can see there is this function that comes from wasi. Inside of it, I basically run the integration code. So this comes from the Leptos wasi crate. I use this handler. That is the main tip that you will use in the crate. And then if I use the same Kaggle Leptos build, instead of so you still have the front end that is packaged. You know, you have your CSS, your JavaScript, the module that will run in the browser. But now in the server side, you have this new target wasm32 wasi P2 that would put a component leptos_wasm cloud.wasm, and now this component is ready to be run on any wasi compliant runtime. So there I will be using wasmtime, which is I think most standard and open source project to run wasi project because it's compatible with wasi. So yeah, the command line is pretty simple. I run wasmtime serve. I give him this component that was just built, and these flags are specific. So as I said, WebAssembly is a sandbox, and there it tells exactly what it has the right to access. So I give it access to my file system, but only the target site package. It cannot go outside of this directory. And I give him access to the HTTP and all of this IO stuff.
Very cool.
Yeah.
I think you might have to give it access to the whole site folder if you have like a CSS file, or am I wrong?
Yeah, it's always on the directory granularity. That means target site package. It use the whole. Let me find it. Site package. So this is all it has access. It doesn't have access to anything else.
So I don't want to gloss over it, right? So basically, crate structure-wise, we've got Leptos, and then we've got Leptos wasi. And you would use Leptos wasi if you wanted to target a WebAssembly framework or server-side WebAssembly with wasmtime. But for most of the people I think who are going to be using it, they can just grab either the Leptos Spin or the Leptos Wasm Cloud integration and basically ignore it, right?
Yes, I think that's most of people will use an end user framework, I guess. So why this is anyway useful? It's because now we have a foundational trait that can be reused by these framework.
Oh yeah, no, I'm I am very happy to have a common base crate for both Leptos Spin and Leptos Wasm Cloud. You know, maybe we'll get a Leptos Fastly at some point. I don't know how wasi they are, but you know, all the integrations, it's great. That's hosted on Wasm Cloud. Oh no, that's local.
No,
host.
that's the wasn't. So I run Wasm-Time. So I run the runtime on my laptop,
Right.
and then I access it there. You can see some logs going on.
Very
saying,
cool.
it's serving the local file, and you can see it has access to the file system because this counter is actually backed by a really dumb
counters example.
Yeah,
we love the
So,
counters example.
exactly.
Sure.
If I just update the file system, this will
Nice.
update that. So yeah, it's really basic because anyway, Wasm-Time is just give you really simple API, but then you can integrate with different most featureful environment. For example, Wasm Cloud is fully WASI compliant. Actually, it's using Wasm-Time under the hood. And so you can run your component as basically anything. And that's the beauty of Wasm out of the browser, is that now we can really run it on a lot of different platforms.
Very cool.
So quickly, for people that doesn't know Wasm Cloud, it's allow you to have your own self-hosted platform on which you can run WASI components, and it's a CNCF sandbox, or maybe computing foundation, incubating project. But of course, this is WASI compliant, but then Spin is also WASI compliant, I think, to some extent. And I think Leptos people already know Spin. So I think the best for now is that I let Mikhail speak about that in more detail.
I'll let Mikhail answer the same question, but I guess I'd ask, what do you think is the biggest difference between Wasm Cloud and Spin? Why would I pick one versus the other? In your opinion, anyway, if you're prepared for that. Otherwise, I'll let Mikhail answer.
I don't know Spin internals enough to know. I think it's just that I knew a bit the community, and it Wasm Cloud use technology that I know. So like Nuts under the hood and Wasm-Time.
Hey, Mikhail.
Hello.
So I'll ask you the same as I asked him. What do you think is the difference between Wasm Cloud and Spin?
Well, full disclosure to begin with, I work for Fermion, who has been creating the Spin project, open source project. The biggest difference? Interesting. I think for Spin, what we have really been focusing on is everything from developer experience and on to, integration with this whole idea of components, like a different set of components than the front-end components we talked about before, but components in the sense of WebAssembly component model, and how you can use that as a developer and, end up hosting these in various places. Spin is quite unopinionated in terms of where you can run things. So basically, the same way that Spin wraps Wasm-Time as a runtime, Spin is also embedded in a lot of in other projects where you can then run your Spin applications. So that would be SpinCube if you run around in Kubernetes. That will be Fermion Cloud, which is a cloud we are hosting, and we have other smaller, bigger projects we're doing with partners where we also embed this, and also just Spin the CLI is one with embedding. So that's a lot about Spin. as Enzo mentioned before, Wasm Cloud, from my point of view, is more focused on the orchestration of WebAssembly itself. Wasm Cloud is called the native WebAssembly orchestrator, and has fairly high opinions in terms of using NATs as a way of doing network communication. But that is also super cool if you want to have scenarios where you need to host and run things across multiple cloud providers and across a lot of different places, where you can do that, because the way that NATs would work in that sense is it will basically take care of a lot of the complexity of being able to communicate across all these places. So there's definitely a lot there where Wasm Cloud makes that much more simple than if, the way that we've done things with SpinCube as a Kubernetes integration is more to just consider Spin being a runtime. Like it's just, you can enable your Kubernetes clusters to run Spin apps, and that's sort of it. Then you have to do your normal Kubernetes stuff to do anything beyond that, right? If you want to do like cluster federation and yada yada yada, whatever.
Okay. Well, thanks for coming on and talking about your crate, Enzo. I will transition over to Mikkel and we'll talk more about Spin and the Spin 3.0 release. I'm very excited about that. So let's get started.
Sure. Thanks. And thanks for having me. And thanks, Enzo, for the Leptos wasi crate. It wasn't until like 15 minutes ago I was actually aware that's how we did the 07 integration, because I haven't really paid attention to that. To be honest, I've been busy doing other things, but really, really nice. And I see Darwin, who's also in the chat now. I know Darwin has been working on getting the Spin template for Leptos upgraded to support 07 and using Leptos wasi as a crate. And there's a whole interesting work going on there. I think the latest I saw in Discord where people were discussing this is the the Fermion Discord, not the Leptos Discord, that there are some breakthroughs. But I know if you have any problems, like reach out to Darwin. I'm pretty sure Darwin is somewhat deep into this. I don't know how much you've been involved, Ben, in the 07 upgrade.
I reviewed the template changes and the Leptos wasi changes, and I facilitated getting it added to Leptos and releasing it. But beyond that, my primary involvement was writing the original Leptos Spin, or writing part of the original Leptos Spin integration. So It's nice to have somebody else doing that. I think it is a bit nicer. But yeah, so.
And I know we've been doing a few streams where we talked about it, right? And there are some great ways where you within Leptos can have server functions being wrapped in Wasm and run as a Spin component and all of that. So definitely go and check this out. There should be a link on its way with the repo of the Leptos Spin integration, so how you can do that.
Yes, absolutely.
But speaking about Spin 3.0, so we released 3.0 of Spin 2-3 weeks back, I think.
Okay.
And it is close to 2.5 years ago since we made the first release of Spin. And I think if you want to look at a sort of an overarching theme, is really the ability to work a lot with this concept of having your applications being individual components.
Okay.
Now, as you talked a little bit before with Enzo about how WebAssembly and wasi P2 or wasi 0.2 sort of changed a lot of things. I think the very big change in there is that you now have a way of not thinking about wasi as a set of interfaces for how you would define what in this world is basically called a world. So wasi is basically a defined set of APIs that you would expect to find in a wasi compliant runtime, meaning if you wrote an application, you would expect to have these APIs available. What the component model introduced in 0.2 is really to say, well, what if there were a way where we could just, like, anyone could define their worlds? Like, it doesn't have to be a wasi. It could be a wasi plus something or a wasi minus something. Or I could come up with my own standard that suits like a very particular need somewhere. So you don't have this WebAssembly world where you either have browser APIs or you have wasi APIs, but you can basically start building your own world, so to speak, using this interface definition language, which then can be targeted from various programming languages, as you mentioned.
Right. A few months ago, I wrote a blog post about how I wrote a wasi P2 component that presents an API for Markdown to HTML conversion. Like you can define whatever API you want, and anyone else can target that API. You can do it in any language so that they all talk to each other. This nice mess. WASI is nice because, traditionally in WASM 32 unknown, we haven't had any access to things like the file system. You'd have to go through the JS API, which we certainly do in the browser, but now you can do it on the server through WASM time, right? So
and I mean, so what we have been doing in Spin 3.0 about this is we've really tried to take some of these features and get them into what we believe is the nice developer experience you have with Spin, and just make it easy. So I think the main use case here is that because we can define create component that exports interfaces, and we can create them in any programming language, so we can basically make them available to the world. You could, to some degree, consider this to be a package manager of WebAssembly components, because you would typically end up using these as you would use a Rust crate. The big difference is, like, it doesn't have to be written in Rust for you to use it as you would use a Rust crate. It's probably in many scenarios more relevant the other way around, where you are in JavaScript land and you want to do image manipulation. How do you do that? Well, you can write an image manipulation library, or as a component, a WebAssembly component. Now you can use that from your JavaScript, and it's not just from JavaScript inside of your browser. It could be from your backend JavaScript API. So making that whole the whole developer experience of doing this really, really easy is something we're focusing on with Spin. And I'd like to show a short demo of a few clicks around, and we can see how this works. Let me just go ahead and I will try and share my screen. Okay, Okay, I have gotten into have not shared my screen on this device before. Let me see if this works.
All right.
Sorry, I should have tried this. Yeah, okay.
It's all good. Just
Sure,
I'll put it up.
Yeah, no, the problem is on my side, because I would have had to restart my browser to be able to do this. That is unfortunate. Can you hold like 2 minutes?
Yeah.
I can be back in 2 minutes. Okay, let me try and be back in 2 minutes. Just give me a second.
Sounds good.
While you work on that, we'll knock out a question from the chat, if that's all right with you, Ben.
Absolutely.
All right. So this is kind of unrelated to Spin entirely, but so Moaz asks, he is very passionate about Leptos and wants to use it instead of React ecosystem. What is your advice? Kind of a general question, because I think it depends on his experience.
Right.
Yeah.
I mean, there's so many ways I could take that question, right? Is the question, do you want to, how do you learn it? How do you use it to best effect? I guess first, generally, I'll go over some of the reasons you might want to use it over React, right? Rust is famous for its compatibility and its resilience. I know personally I've written Rust web apps that I've come back to in a couple of years, and it still runs perfectly fine. Like I've also worked on JS projects where I write something and then some of the JS libraries update, and then it doesn't work a month later, and I got to rewrite parts of it again. There's definitely that dynamic. There's performance reasons, a Rust backend and a Rust front end, but the Rust backend is faster and will handle more users. The Rust front end will render your page faster. All that part doesn't really matter so much. we're roughly equivalent to React, or mostly better in my opinion, for things like bundle size and bundle size and render time and time to interactive and stuff like that. And then I'd say that the Rust ecosystem is a lot more stable, right? Like there are so many new JS libraries or JS tools, bundlers, compilers, plugin adders, all those things are getting written in Rust now, and there's like 12 options. The Rust versions are stable and consistent and pretty nice in my opinion.
Yeah,
For sure.
I would say, I mean, my advice if you're trying to learn Leptos is to build something very basic in React and then build it again in Leptos. Like just do something in React so you've got a good mental model of how that comes together, and then I would just do the same thing in React. I mean, I'm sorry, in Leptos, and I would also maybe try and do something super, something super simple, like just like a contact us form with a server function or something like this.
Absolutely.
Yeah.
We have a lovely book that kind of starts at the basics of fine-grained reactivity and signals and builds all the way up through how Leptos works. I think it's fairly similar to how you're familiar with React, but signals are a bit different, and the Rust way of doing things is a little bit different. Not much, but a little. So.
Yeah. All right, cool. Well, I think Mikkel, you're ready to
Yes.
to go now. Okay, cool.
So, do I need to put my own screen in here?
Oh, I can put it up on stage. I got
Okay,
you.
cool. Thanks. Hey, there you go. Okay, yeah. Let me know if font size is okay. So what we've done is we have this example, and I'll share a link to GitHub later so you can see this. But basically, what we've taken is we've taken a we're using the Photon RS library in this code that I'm showing you here, and basically implement a library that does grayscale and sepia manipulation to an image. So this is just your usual Rust code. So there's a few things going on in here. You can see we have these bindings, exports, and things going on, but don't worry too much about that. But I mainly, what I want to show is just like how this workflow would work, right? So I would write a library here that just like has these few functions defined, and the way that I defined what I have inside of my what I implement inside my library is using the WIT language, and this is what Enzo was also showing us before. This is also how wasi is described, by the way. So a wasi HTTP component, which is a standardized interface, is one of these that takes an HTTP handler, returns an HTTP request. In this case, you can see I have an image manipulation interface. It has a few error variants down here. It has an image, that's a type, and it has these two functions. And basically this image world exports the image manipulation interface, which means that when I go ahead and build this, so cargo component, you probably use cargo, or you use cargo component build in this case, and target wasm. Wasi, I think you can target unknown with this one, as long as it doesn't use file systems. And those type of things. There's a little bit of like, you need to figure out, if you are relying on WASI stuff or not in what you implement. But I guess this is only pure memory we're doing here. So basically we can create a component like this. Let me get out of this. So cargo component would be the command to use. And then actually this was inside lib, wasn't it? Yeah. And then we can generate our WASM file that is now this image manipulation library. And what's interesting is once you have these WASM files, and again, we could have implemented this in any programming language, and the WASM would not necessarily been the same, but it would have been able to. I probably need WASI. Let's do WASI instead. It would be able to implement the same functions and do the same stuff. So once you have these WebAssembly components, we can go ahead and use a tools called WASM tools. and we can try and figure out what is the actual set of interfaces that a given WebAssembly that we have. What is it exporting? What is it implementing? So in this case, if we take a look at, I think we did the debug build. What we'll actually see now is we'll see a representation of the WIT that is being written off of the WebAssembly that we have, right? So inside of the WebAssembly bytecode, we not only have the actual implementation, but we also have the necessary interfaces being described. So headers, basically, right? Is what's going on here.
So let's say I deploy an app to Spin, right?
Yes.
Leptos app maybe, and I've got this, and I want to use this in my Leptos app. Can I connect the two on the Spin platform?
Yes, exactly. That's the thing you can do. And this is what we made really easy, because working with WIT interfaces and defining WITs and so on and so forth, there's a lot of tooling involved. I would say this, from a maturity point of view, this is still at the stage where if I would have to do all of this from the get-go, I would like have 5 or 6 different tools involved, and that's not a great user experience. But what we've enabled with Spin 3.0 is that once this WebAssembly component is now created, I can push it into an OCI registry. So WebAssembly uses OCI as the registry, which means that, you know, they are available everywhere, and you can easily set up your private one. I think that's the main takeaway there.
Like a Docker repository?
Yes, something like that. Or you can run Harbor or something yourself, right? There are a lot of these places where you can host these things. But then what you would do inside of Spin is that you would actually run a command called spin deps, which is spin dependencies. Sorry. So you can say, I actually want to add in a dependency, and you can reference directly from a registry a given wasi package. So I would, for instance, have, I'm not sure I remember exactly where I put the one that I had in here, but you know, I would use a registry. There's a package name, there's a version in there, probably 0.1 or something like that, whatever this one was called, right? And the next thing I would do is, because now Spin would know that I am using an external WebAssembly that needs to be, you know, pulled in at runtime or deployment time, whenever. It depends on how this is implemented in the embedding. Then the next thing I would need is I would also need the bindings in the programming language that I want to use to target the WebAssembly, right? So this is sort of the second step here. So I will go and generate bindings in this case, and I will now generate bindings from Rust. Now the example doesn't make sense anymore because we were originally in Rust, but let's just say like we didn't know where this came from. We didn't know what programming language this was written in, and we actually don't care. But we can get these bindings based on that WIT information that was present in the WebAssembly. And then we can get that into our application. So what this will end up look like is that in our Spin file, you can see that we have a particular component in here, which is called image manipulation TypeScript, or TS. So that's the front end that we built, right? And this is the one, sorry, this is not the front end, but this is the back end that needs to do image manipulation. So it is going to take a dependency on this particular. So this was the world or the interface that was defined inside of the WIT. And this is basically where it would go and find it. So go and find this in a registry called fermion.com, and this is the package to download. And then what we can do inside of our image manipulation, and now I'm gonna show you TypeScript because that's what it is. That we are importing these functions from that component, and basically what we can do is we can now just call, well, not transform, we're calling it somewhere down here. What are we calling? We are calling grayscale and sepia. There you go. So we're basically calling these Rust functions now from an inside TypeScript. And you can see how this is then, and this is, so you would be able to do, to your point, Ben, this is what you would do in a server function, for instance, right? In Leptos, where you could then mix this into how you can use the key value store that Spin provides. So in this case, we are caching the transformed images in a key value store. I don't know if this is necessary or not. I mean, if you have high traffic and you want to serve the manipulated image, maybe you want to do that. Other than that, we're just probably just wasting disk space somewhere rather than transforming on a request. But you sort of get this idea, right? That you can take these components in coming from other programming languages and start mixing them in with some of these spin features. And there's a fairly straightforward and easy way to do that.
Awesome. I mean, is there a place like crates.io where I can go and find a whole bunch of these with predefined interfaces and just pick and pull into Spin?
So the answer is not really, because this is not a huge ecosystem yet. But there is one place called wa.dev that is starting to show some of these. So for instance, in here, you would be able to find Spin. Let's see. Oh, let me go. Sorry. You'll be able to find the Spin interfaces and the definitions. I'm not sure you can necessarily find the packages directly in here, but at least you'll be able to find some of these interface definitions. I'm not sure whether they have implemented the function, the feature to actually have a, a place where you could go and then, what's the reference or what's the registry where this would be or not. So this is still evolving, right, as we move ahead with the whole WebAssembly stuff.
Sure. Is there a difference? I know it's all compiled to WebAssembly, but if I write my component in Rust or I write it in Python, is there a difference in the end game performance?
I mean, it all depends on. There probably is, but it all depends on, because it doesn't compile to the same code, right? It
Right.
compiles to the same type system, and I think that's the main thing, right? And so, for instance, in languages like Python and JavaScript, the way that most of the WebAssembly, I wouldn't call it compilation, but actually it's the interpreters that are being compiled, and then the scripts are being packaged into the WebAssembly. So you would tend to see that JavaScript and Python WebAssembly are much, much larger than Rust WebAssembly, for instance. It's sort of a state of these languages and the support that they have.
Right.
And it very much differs from language to language in terms of how well supported they are with WebAssembly, and then what the impact of something like size and performance would be based on that.
Right. Someone showed me TinyGo recently, which I guess is Go without a garbage collector for WebAssembly, if I'm remembering right.
I think TinyGo comes from like embedded, like Word,
okay.
created to target embedded scenarios. So TinyGo has historically had better WebAssembly support than, well, we call it Big Go now. I know we're not supposed to, but than Go, regular Go. But I do know that wasi 02 or wasi P2 supporting Go is something that is being worked on right now.
Okay. I mean, that's fantastic. Which languages can I use, right? I know Rust, you said Python, JavaScript.
Yep.
How many choices do I have these days?
You have a lot of choices, and I think we have actually compiled a list of languages and the state of their support. I will see if I can find the link. Basically, if you go and search for WebAssembly language support matrix.
I think it's under supported languages. I think I have it here. I'll share my screen.
Oh, okay.
Very cool. Oh, look at this. Okay. That is a lot of languages.
Yeah, and it's important to know the difference in between, core WebAssembly and then browser and WASI as those standardized like browser APIs and the WASI APIs, and then whether we build an SDK for Spin, particular for that programming language.
I gotta ask, why is PowerShell on here with all X's?
That is actually a really, really good question. Oh, you know what? No, I know why. It's because I think well, I don't know why. Like, this is me trying to go. I think the headline is that we actually took RedMonk's top 20 languages and used that as sort of like if we compile information about those top 20 languages based on what RedMonk is sort of how ranking them, what can we tell about WebAssembly rather than picking and choosing ourselves. So we should pass that question on to RedMonk.
Let's say that I'm starting a startup, or I'm building a product, or I'm a company that has a Java monolith or something like that, and you come to them and you're like, you should use Spin for X reasons. Like, what is the selling points for Spin / WebAssembly in this way?
I tend to talk about it in the way that Spin is even though it uses WebAssembly in the same way that Leptos uses WebAssembly, you can sort of like, you don't need to necessarily be involved. Like, it's an implementation detail in the sense that we believe that that's the right way to compile and deliver this, because it gives us a bunch of benefits in the experiences we want to create, in the products and projects we want to create. So for Spin, we think about Spin as a serverless framework. Really, this is how you would build serverless apps. But what makes this a lot better than other serverless frameworks is that because we use WebAssembly, we have very small compiled binaries that are very fast to start, that has the sandbox that Enzo also described earlier on. So there's a defined set of APIs, and there are guardrails at runtime to say whether those APIs can be used or not. And then there's polyglot, two ways. There's both polyglot, like you can compile from different language, but there's also portability in that it can run the same binary runs across programming languages and platforms. And because of all of that, it's actually it's a perfect fit for a serverless framework as a technology like that. Like we have tested the density of running Spin applications inside Kubernetes, for instance, where we could host 5,000 applications on a single node. We have built runtimes. This is not how Spin the CLI works, but we have built runtimes where we can actually host multiple applications behind a single host process. So basically, and the reason here, one of the core things that we do is that, because you saw again how Enzo described with wasi HTTP, the interface between the host and the application that you bring is that you implement an HTTP handler, right? You expect an HTTP request and you return an HTTP request. Once it gets to your app, it is just an object in memory, right? It's not network involved, like the host take care of that. But what we can actually do is, in an environment with a lot of different applications, where a lot of traffic goes to different Spin applications and components, we don't have to have the WebAssembly component that's the HTTP handler. We don't have to have that in memory. We don't have to have it loaded. It can basically sit on disk, and once a request comes in, we can load it and hand over the object and get it back and unload it again. So this whole idea in terms of how at runtime you would have to scale things is sort of just taken care of. So you could say in theory, and I know this is theory because there's definitely things impacting, but whether you would have to serve like 5,000 requests from 5,000 different handlers or from a single handler, you should in theory get the same performance, right? And those are some of those like really interesting things we can do, which means that you can break down your functions in basically functions, like very small functions. And I'm not sure if we do that with Leptos today, Spin Leptos, if each individual server function is its own WebAssembly. I'm not sure it is.
I don't think we're doing that, but we probably could.
But that is something you could do. I mean, it's not like, I don't think there's like huge benefits into breaking everything down into, that small bits and pieces. Yeah, that granular, but you kind of get the idea, right? There's a bunch of stuff in there that's super interesting. And particular in scenarios where you want to have, like you mentioned, Fastly, right? Like if people want to move, and we see a lot of people want to move more and more code closer toward the edge, like from big data centers and further out. I think WebAssembly is an excellent technology for that, and having a serverless framework like Spin at the edge is something we would love to see soon, hopefully.
Very nice. I'm excited to try out Spin 3. I admittedly am still running my blog on Spin 2, so I'm not quite sure how much work I'll have to do for that, but it'll be fun.
Runtime wise, should work as long as you start upgrading the SDK and everything. There might be some changes, but yeah.
Nice.
Yeah, and just for anybody watching this and listening who hasn't yet tried Spin, it is an absolute breeze to set up and get up and running. Fermyon has a great free tier. I mean, you can literally have a Leptos app up and running within literally like 5 minutes. It's like a few commands, and you can have it deployed to a custom domain within 5 or 10 minutes. It's really crazy how streamlined they've got Spin. One quick question. So, of course, you do have Fermyon Cloud that you can deploy there.
Yes.
Let's say somebody's got a VPS, they're going to have a Hetzner server or something like this. And I'm pretty sure I already know the answer to this question, but more for the audience. So you could also just use your VPS and just deploy Spin onto that VPS, or help me understand that.
Yeah, Spin works as a CLI. So you can run Spin up is basically the command, and have some automation to make sure it runs on your server. That's how you would typically do that. Kubernetes is always something. So if you have a Kubernetes cluster, the project is called Spin Cube, and that basically enables you to deploy Spin applications the same way you do as containers. We don't run them in containers because we inject the runtime at the container runtime layer. So it's also super efficient. Then you can also create your own Spin. This is a nice. So in 3.0, up until 3.0, we made a huge sort of internal refactoring. Basically, we created a concept called Spin Factors, where you can think of it the same way that you can sort of use components on top of Spin, like you implement your HTTP handlers and things that are components. The way that Spin itself is built is also through a bunch of factors that implement all these features. So the fact that you have KV store, key value store enabled, the fact that we can support HTTP triggers and other type of triggers that are enabled in Spin, all of these are implemented as factors. So you could basically take Spin as a bunch of crates and create your own little runtime embedding of Spin if you so desire. And yes, Spin is a Rust-based, written in Rust as a framework. So I believe a lot of people here would find interesting going and looking at how all this works.
Yeah.
However,
Yeah,
it's not for the faint of heart to go and do your own Spin. But I mean, if you want it, you can decide what type of features you want to have in your Spin.
Yeah, I mean, but that's cool though, because you have kind of both ends of the spectrum there. I mean, you've got on the one side this very, very turnkey experience with Fermyon Cloud, or you can go to the other end of the spectrum, which is super exciting.
Yeah, that's true.
Yeah.
I mean, heck, I've enjoyed. I still have a couple nitpicks that they don't seem to be fixing, but overall, I've been very happy.
That's good to hear, Ben. It's good to hear.
If I could get you to verify domains without transferring the name servers.
Yeah. Yes.
The mail exchange server, yeah.
Okay, there's a GitHub issue on that. I will defer anyone to that issue, and let's have the discussion there. Let's not do this here right now. But yeah.
For sure. There's only a couple little things, and you can get around it mostly.
Yeah.
So
Yeah.
All right. Well, I want to open the floor to any questions people might have in the audience here. I don't see any right now, but if you have any, please post those. Otherwise, thank you, Mikkel, for coming on. It was great to have you.
Yeah.
Let's pull in Greg. Maybe Greg has a question, but since Greg's here now, I want to, give him a huge shout out for all his work on 0.7, for sure.
Thank you. Yeah, no, I don't have any questions. I've been listening in, enjoying the conversation, and drinking my cup of coffee as I switch from work mode to fun mode for the day. So thanks so much for joining us. It's been really awesome, and I'll look forward to going back and listening to the part I missed before. And hi, everybody.
There we go. It might take it for a spin. That's a good one.
Yeah.
I'll ask, So now that 3.0 is out, what is like the next big thing for Spin? What are you excited about moving forward?
That's interesting. I think one of the things we did from the very get-go with Spin is we kind of Spin always have had this concept of components. So basically, when you build a Spin application, you just have various WebAssembly projects, smaller things that you bundle together, and we call those components. And they are WebAssembly components, but it's sort of components in the world of Spin, not components in the world of WebAssembly. So I think there's something we need to untangle there now that WebAssembly component has really become a thing. And I think part of that is also the story of we really, really want to make sure that Spin has a really, really good developer experience if you just want to work with WebAssembly components. Like, it doesn't have to be that, like to Enzo's example previously, if you build a Spin application today, you can actually produce a WASI HTTP compliant handler, meaning you can use Spin to develop the application, but then you can run it inside of Wasm Time. You could actually run it inside of Wasm Cloud. You can run it inside of other places because we have these standards. I have a repo laying around somewhere where we even run this in NDNX unit server because they also implemented the WASI HTTP world. So there's a work going on around standardizing these interfaces where you could say above HTTP, WASI HTTP, there's something called WASI Core Cloud. That is a collection of interfaces where HTTP is one, key value stores is one, configuration, I think observability. There's a bunch of interfaces that is defined in there. The idea that we're working towards in sort of the ecosystem is if you have built an application that targets the WASI Core Cloud world, you should be in a spot where you would have multiple providers that provide that world as a hosting options, right? Whether that is a fully managed service like something like Fermion Cloud, or whether that is one of like, the bigger cloud providers who have these, or whether it's a concept inside something like Kubernetes, you can see how this idea of a WIT world sort of comes together, and you create an application to live in a world. Now you go and find a world that would host your application. So making sure that Spin is a really, really good developer experience to create these type of applications where you could say, even from the beginning, like, you saw the example that I did where I tried to build my library and I used the wrong WASI target. One of the things we want to do with Spin specifically is say, like, now I want to build an application targeting this interface or this set of interfaces or this world. Now, along the line, how can we guide you? How can we ensure that you're only using the APIs that are guaranteed to be within that world and not something else, right? So you can sort of see how there's a story there that we really want to get
build time
together.
API verification. Interesting.
Yeah.
Cool.
I mean, I love the concept, coming from your deployment options, right? You've got something like Vercel, where if you go there, you're basically locking yourself in mostly, right? You can kind of work around it with a bunch of additional things, but there's a bunch of Vercel specific features. Docker files have kind of become the thing. You can take your Docker file to many places. Most of the time that works, but they take a while and they're large. But the idea of having WebAssembly modules that are small, can run in any environment, don't need to be recompiled across architectures, I'm very excited about that, and I really hope we get some real traction. So
I think it's also a really good sign that a lot of that you all and other kind of frameworks are involved in those standardization conversations really deeply, and that it's about standardizing between you. It strikes me that there's a parallel to the web components thing that you're avoiding, where there were frameworks that had framework components, and then there were people who wanted to build non-framework web components. And what we've ended up with is a world where web components don't really work that well with any frameworks, and none of the frameworks really work that well with web components. And it's just like added another standard as opposed to actually standardizing on a thing. So I'm really encouraged to hear about that progress in working together and kind of standardizing. Like, there's always you're saying you had your components and now there's a standard component, and okay, how can we move over there? Which is always hard, but it's really important and encouraging work too to actually standardize on something.
Yeah. Oh, yeah. It really is. And again, because of the way that the component model is built, you can always extend, right? You can say, I have all the interfaces in the standardized world, but I also give you these additional interfaces, right? And that's how I extend and bring something else. And whether you want to up into that or not, but we can find that, baseline that is supportable across multiple vendors. I do want to highlight that Microsoft did announce last week, I think they had a big conference last week or the week before, that their Edge service, which is called Front Door, I think, something like that, would actually start supporting these type of WebAssembly components in the near future. So at least having some of those statements coming out where it's like, okay, we know that more people are onto this, and it's, we've seen Cloudflare doing some work with workers, not quite there yet, and we've seen Fastly doing some work as well on Computed Edge. So yeah, I hope we'll get there. And there's this one small thing that I didn't get to mention earlier, Ben. I just want to mention in terms of Spin 3.0 is we've actually done work across Spin and Spin Cube, where we can sort of also go in terms of components, go the other way. So part of what we've done with Spin is there's this idea, if you've done a lot of microservices development, that it gets really hard to sort of to get an idea or reason about a system or even an application, because where is this code base, where is that code base, and you kind of all like, it's even a conversation about mono repos versus not and all this. But what you can do with Spin is you can actually build things as small individual services and have them all work together on your local machine, because the WebAssembly world, we can abstract everything away and then make it work. But we've also made a feature now where we can do what we call selected deployments. So basically you could say, I built 5 different components as part of this application, but when I deploy them, I want to run 2 in this place or 3 in this place. I want to have some running on the edge. I want to have some running my data center. So you can sort of go from having everything on your local development machine, but then at deployment time, an operator, whoever is gets to decide where these things go, based on resource availability or other types of constraints that you may have for these components. And that's sort of another way of how this, componentization or building with components or composing applications, whatever you want to call it, where that also has a value.
That's great. I mean, I know everybody's talking about something on the edge, database on the edge, compute on the edge, so being able to distribute those things is nice for sure.
Yeah.
All righty. Well, it looks like we have a few questions that are Leptos related. So I'm thinking, Mikkel, we can close this here, and you're welcome to stay on. And thank you so much for coming. It was a very interesting conversation.
Thanks for having me. I will jump off now. I have family waiting with dinner and everything, so I'll go and do that. And thanks for having me. It was very nice being here. Nice seeing you again, Ben. Nice meeting you, Luke. Nice seeing you again, Greg, and everyone else on the call.
Enjoy your evening.
Absolutely.
Thank you.
Thanks
Have a great day.
Take care.
Bye.
All right.
All righty.
Welcome, Greg.
Hey, yeah, nice to be here. I don't have anything to say beyond what I've said over the last 15 meetups about the coming 0.7. I think I was just pushing the button to update our website and put the new updated playground on the website that somebody pointed out on Reddit. Somebody very, very nicely posted the release notes onto the Rust subreddit, and there's been a really nice conversation there. And I put up a little bit of ask me anything. So if people want to put questions in there, of course, you're also totally welcome. But also, yeah, here we are, and really happy to answer whatever questions people have. So, yeah.
I think we could probably just jump right into Chris A's question from Discord. So he posted in Discord, but he's also posting here in the chat. So I'll read from the Discord. I'll just read it all. So is it generally better to quote unquote go wide on the resources needed for a particular page, perhaps building or bundling them into a struct? They've got resource dependencies that get nested under components. It seems like that might be linearly sequencing the server calls that return the resource. And then I think actually the other question is separate. Yeah, so
cool.
Let's do that first.
So I'm happy to talk about that. I think this is a great question that I want to say on stream, just so that anyone who has had this question or doesn't doesn't know how it works can hear the answer too. So yes, going wide is a good idea. And let me explain what that means. So if you're listening to this, you probably know that Rust future is lazy. So creating a future doesn't do anything until you start polling it. But once you start polling it, it starts doing the work. When you create a resource and you pass it a future, or basically when you create a resource, right, it calls that function you give it to make a future, and it starts polling it right away. And the reason that we want to do that, right, is as soon as you say, hey, load me this data, we want the data to start loading. So the data starts loading where you create the resource, not where you use the resource. In that way, it's a little bit like how a JavaScript promise works, not like how a Rust future normally works. Because the goal of that, right, is if you create 3 resources at the top level of your page, and then you only read them further down, the data will start loading as soon as you create them, and it may even be ready by the time you read them. If you create a resource, you read from the resource under suspense, and then you create another resource underneath it, this second resource will, it's called waterfalling, right? You'll load one, and then you'll start loading the other. And sometimes that's unavoidable, right? Because sometimes the second one genuinely does depend on the result of the first one. And one of the big changes in 0.7 is that you can now await a resource, including inside another resource. So you can await the first resource in the second resource, right? So you could define them both up here, and the second one will just wait for the first one. But if you do need to do it under suspense, that's fine. But if you can hoist it up to a higher level and start loading, that's really good, because now your data, your 2 different kinds of data are loading concurrently. So say a classic example would be a blog post and the comments, if those are stored separately. So say you're doing 2 different database queries. Maybe that's a bad example, but whatever. Maybe you have Discus or some other service API, right, that's doing the comments. You want to start loading the blog post and start loading the comments at the same time, rather than loading the blog post, waiting for that, and then underneath that suspense, start loading the comments, because doing them concurrently, it will just happen sooner. So basically resources start loading wherever you create them. So you can read it underneath the suspense, but if you've created it up in the component where you created the other one, they're going to load concurrently, which will end up feeling to your users like your website is twice as fast, right? If you make a database query and then another database query, as opposed to doing 2 database queries, it's going to feel like it loads twice as fast to do them concurrently. So you generally do, I always say to people, you want to hoist them up to the highest level where you have the information that you need to start loading them. And if you want to use it lower down, okay, maybe you pass it as a prop or you pass it via context or something. But you want to start loading them as high up as you can, basically. Maybe even like at the route level, right? So when that route starts loading, wherever you end up using it.
Got it. Awesome. That was a great explanation.
To go on a bit of a tangent, I think we had this discussion a little while ago that like there's a certain number of resources that we can have in a page before things degrade.
Yeah.
So
yeah. Well, so somebody opened an interesting GitHub issue where there was a Stack Overflow, and when they gave a reproduction, it was because they had 1,001 separate suspense components. Like and it sounds silly when I say it, but it makes sense when I describe the situation. So they had something where it loads, it was images actually. So it loads a list of 1,000 images, and then they had a for component, and then in each of those, it created a resource to load data specific to that image and had a suspense to wait for that data. But the problem was just with out of order streaming, right? It puts a little bit of a script tag and a little bit of a template to send that down. And it was actually something in that process was overflowing, but I was really glad that it was panicking on the server during dev and they were opening an issue about it, because like if they did the async streaming mode or the in-order streaming, it didn't overflow. And it was actually, I think if it with the out of order streaming with those little template and script tags, it was 450 kilobytes of HTML they were sending down. And with the async or the in-order streaming, it was only 150. So like rather than shipping 3 times the web page, which just destroys your performance, SEO, all of that, right? It was overflowing. But so yeah, don't try to put 1,000 suspense tags on a single page in debug mode. I think when I tested, even in dev mode, it got up to like 300 or 400 before there was any kind of a problem on my machine. So probably don't have 300 of them either on your page, but like Suspense is designed for sort of 3 or 4 things on a page, right, to load in, and you can make those bigger than just one resource. Yeah.
Waterfalling is fun. Suspense is like all this stuff is like a little bit of black magic in there for sure.
Yeah.
We can just move on to
Good.
Chris's next question, which is preventing reactivity bugs. Other than maintaining a strict separation between resource instantiation and consumption, how can I use types for this? Context: I was in the Discord really confused by some panics arising from reactivity bugs and the fact that what order.get was called in relative to returning value surprised me. And the context is relevant to 0.6. I can put this up on the screen.
He added a little bit more context at the very bottom of that, if you want to read that.
It's a great username, by the way.
Yeah, it is. I think this is second question. I think part of the issue was components are isolated. It wasn't clear when I should be passing the resource or the post get value from it to the component.
Yeah. Okay. So I mean, with the without knowing the specifics of the situation, right? So this may not speak to your situation at all. Sorry, but in general, when I see people run into issues with resources in particular, it tends to happen around this weird disconnect where you can use them like you could use any other signal, but they're this async data loading thing where when you're using out of order streaming, which is the default mode, the server is going to have sent down a version without that resource. And so if you somehow get into a weird situation where, okay, I .getted it inside a memo and I pass that memo somewhere else and I pass that somewhere else and then I derive a signal and then I read from it. And then you're like, wait, why is this thing broken? Because ultimately it derives from some resource that existed outside of Suspense or something, right? So like the updated version, once it finished loading, didn't get sent down from the server and there's a hydration error. I don't know if it's that sort of problem that you're facing or something else. But I would say it often is when people, the problems that I've seen and that I've helped people with in issues or on Discord often involve almost like a kind of extreme level of abstraction over the fact that you're loading some data asynchronously. And I almost worry that the defaults are maybe set to make things a little too complex and powerful when the default should maybe err towards simplicity and less power. So like maybe in some cases saying, okay, I'm going to step back for a second and just put SSR mode async on everything and see like, and just load my resources and just in 0.7, right, await the data at the top of the application and then pass it down. And particularly for a resource that you load once on a page that you're not reloading and stuff, and just sort of try to like move things up to that top level so that you're dealing with more plain data for stuff that is like that, where it's like a blog post I'm loading once. I don't click a button and need to refetch the blog post. Like it only updates when it's written or whatever. So for things that don't need to be particularly reactive, trying to almost remove some of that power and see if it can remove some of the complexity. But yeah, I mean, again, I don't know if that has anything to do with the specific situations you're talking about, but those are the sorts of places where I tend to see people getting tripped up. And again, right, it's something that doesn't happen with regular signals because they're not asynchronous, like because they have a value on that's defined in the code. And so what the value is on the server and what the value is on the client is the same. And then if you create all these memos and stuff, like that all just flows through fine. But it's specifically around that weird way in which resources don't behave like other signals, even though you can access them synchronously like other signals.
They're definitely special.
Yeah, they're definitely special. And again, like I think that hopefully the new release and the new async model is helpful in that you can, like I've seen examples already of people saying, I created a single blocking resource at the top of the page, and then I use suspend and I await it. And then I just pass that value as a prop to the rest of the application. And like, that's pretty good, right? It gets around some of those issues. Yeah.
Yeah. He says, finally, I'll just wrap this up. So he says what happened is he was returning views under suspense and had to get unwrap, other resources after the early view return.
Yeah. Yep. I remember that issue totally. And it has to do with, right, the way that suspense, this is why that await stuff is good, because it lets you actually wait for something, as opposed to just the problem in that. I remember that very specific situation, and I've seen it from other people too. It's a super understandable situation, is right. The suspense, if you basically, you can't early return in Leptos or in Solid or in similar reactive frameworks, unlike in something like React, because the component only runs once. And it's the same with suspense. So if you early return, the rest of that code just kind of doesn't run. So like when you early return before you read from the second resource, the suspense never ends up tracking the second resource. Like it doesn't know that it's waiting for the one because you returned early before it read it the second time, or before it read it the first time rather. And whereas with 0.7, right, with suspend, with the async block, if you await the first one and then how would an early return work? Yeah, that's actually interesting. If you awaited the first one, but you were early returning because it was none, right? It was basically a way of awaiting in a sense. So yeah, totally. That's again, like there was a reason to try to change some of those APIs around and let you await resources basically. And hopefully that helps.
Yep.
Have we gotten any your questions? Yeah.
Yeah. So we have another one. I think this one is more of just a question about just a general update. Do we have any information on WASM split?
So that's a good question for me, because I'm doing most of the WASM split stuff. I'm almost done upgrading Cargo Leptos to be a little bit more flexible, a little bit more versatile. The old version, the current version / old version, is a little bit inflexible in how many different things it can compile for and all the different options that we've added on. Turns out people want a lot of things from their build tool. And one of those things that I'm doing is I'm adding WASM split into it. From what I've tested so far, it seems to work quite nicely. You do kind of have to manually annotate your app with split points, but you kind of have to do that in JS anyway. So I'm looking to get that out sometime in the next couple months. I mean, especially now that I've got paid time to work on Leptos through the new gig, I imagine that'll speed up quite a bit as well. So keep your eyes open for that. I will try to finish it.
Yeah. And for anyone who doesn't know, I am doing a talk at Rust Nation UK in February on the future of Rust web applications. And I would love to be able to demo something having to do with this at that. 0.7, you remember, I mean, I did some demos over the summer, right? Like, so we can do a manual version of it, right? It's just a question of making it actually usable for everyone. But the 0.7 router was designed really specifically to have the right APIs to support WASM split and lazy loading and stuff. And obviously getting 0.7 into shape to be actually released, it has been a really long process and hopefully has gone well. I don't see too many issues popping up in the issue tracker since yesterday. But so yeah, that was kind of like underlying work. And then Ben has been working on building it into Cargo Leptos so that like right now you can do it manually as a proof of concept with the 0.7 APIs. And then Ben's been working on being able to do it kind of built into Cargo Leptos, which is awesome. So yeah, I mean, coming soon, it's kind of on the next, the agenda for the next set of things to be worked on.
That and the new server function error thing, which we kind of talked about in the announcements for 0.8. So the big things.
So we have.
Go ahead.
Go ahead.
No, you go.
I was going to go to the next question unless you had anything to add there.
Go ahead. I was just going to say.
Okay.
Yeah.
All right. So we have one more question. And I'm not sure I understand the question. So, okay. So Moaz asks how to effectively handle delay while design UI hot reload.
Oh, sure.
I can take a stab at that. Well, I mean, there's two parts of it, right? There's minimizing the delay, which is always nice. There are a bunch of tricks in Rust that can speed up your compile time and reduce that delay. I've got a blog post that talks about a bunch of different ways that that's achieved. We do have hot reload, which Luke, you linked him. that if you change like something basic, like the HTML or the CSS, it will update the UI in the browser while immediately and then recompile the site, right? I don't know if you've got any other tips on that, but most of my compile times are less than a second or a second-ish, and I found that I basically don't notice that. At least that's my experience.
Yeah, I mean, I think that the answers are there are a couple of different categories of answer, right? One is the general Rust compile time tips. So tweaking settings in particular ways to make things quicker on the compilation. And there are lists of these things that you can find. Ben's blog post is a great example. The second one is particularly as applications scale up, I think it's really, really important for people to remember that the basic unit of compilation for the Rust compiler is the crate, not the file or the module. So if you have an application that's in one crate with 30 files in it, say, and you've got 30 pages in your application, and you change one class name, and then it's recompiling that entire crate, all 30 pages, right? Every incremental change. And one way that you can really cut down incremental build times in Rust in general is just by breaking things out into crates. So as your application scales up, if it's a large thing, you may find that you have a bunch of different crates divided up by, say, feature or part of your application. And then when you're working in this feature in crate A, it's only recompiling crate A and then the final thing, right? The other, so that's kind of like Rust compilation. The second one is when people say hot reloading, I never know whether they mean the kind of cargo Leptos watch live reloading feature or the -- hot reload. And if people don't know about the -- hot reload, that is something that does its best effort at, it's only supported on nightly, and it's a cargo Leptos feature. But it does its best effort at reading the view macro and then comparing that to the old view macro and then just sending patches straight across to the browser over WebSocket before the recompile. So that delay should be really short if that's working, and it's not a perfect feature. And then honestly, the third one, right? And people don't always like to hear this because styling is an opinionated thing, right? Part of it depends a lot on how you choose to structure the ways you're styling an application, right? And if you are super devoted to inline styles, Tailwind, and so on, this answer won't be helpful to you. But if you are writing an application in such a way that your view is like semantic HTML, that's like, here's the content of this page, and then the way you're structuring that is by writing CSS that shows how to display that HTML. Well, CSS reloading is instant, right? So I think that the hot reloading thing, the iteration speed thing, I think comes a lot from a style that works really well in JavaScript, where you're just like doing this very tight loop of Tailwind classes and stuff, and tweaking markup and so on. And I think that there are other ways of working and designing. And again, like that's probably an unpopular answer for people who like those approaches. But like I don't tend to encounter a lot of issues. I tend to use CSS or SCSS for styling, and so I tend not to encounter those kinds of issues because when I'm tweaking stuff in a CSS file that just gets instantly sent back over to the browser. And then occasionally I'm changing the HTML structure of a page, or I find that I tend to do a lot of like writing business logic and being in a cargo test kind of loop. And then there's kind of like a run through of the view. And then there's another thing of kind of updating CSS. But that's, again, just like different styles. So that may not be a helpful answer, which is why we try to work on the hot reloading and stuff too.
Bite My App mentions that they'd like to prototype CSS changes in the browser, which I've certainly heard people do. It's not one of the things I typically do. Mostly because I don't really know how to get the specific CSS changes back out if I change like more than one or two things. I tend to miss them, but I'm sure that works better for some people. I'll highlight, you mentioned it earlier, but I'll highlight the idea of workspaces. Leptos has workspaces templates. I've worked with a few people at this point who have a Leptos app who get, a pretty large app, but it's all in that single crate, and then it all slows way down. And I'm just like, oh man, you really got to use the workspace and put the different things in different crates and split that stuff up. because it will trap you later. And I don't know if we do a good enough job highlighting that at the beginning.
Yeah, and especially now that in 0.7 the view works almost like a kind of parser combinator or iterator library works. And different Rust project just for fun that I've been working on is like a little compiler, and it uses a parsing crate that's built like that. And I realized at a certain point, like it was like 15-second builds, and I was like, this is infuriating. I don't want to work on this project anymore because every time I save something, it takes forever. And then I just split the parser out into its own crate and went back to like half-second builds, because if I wasn't changing the parser didn't need to recompile. So just like even splitting out a few small things can help a lot with that.
Yeah.
I mean, and then there's like the far-fetched things, like maybe Deoxys is going to figure out Rust binary patching, or somebody's going to do that. And that'd be great. I love that. But, you know, for now, we'll have to muddle through.
Yeah, exactly. Do we have other questions from people?
I don't think so. I think that's it.
Awesome.
And I would be perfectly okay if that's it, because I'm in Australia and it's almost 3 a.m. and I have a system upgrade in like a few hours that I have to do for
Yeah. Yeah. So you go get some sleep. Sorry I joined so late, but I'm glad I was able to see you all. And
we just had so many great people. We went over time. So.
Totally. I honestly, like, I was seriously thinking about just handing this one off to you, Ben, but I was like, no, I want to be there. I want to be there for the spin guys there. So, yeah.
Anyway,
all right.
yeah.
Well, do we want to tease the potential holiday stream and invite people on?
I haven't mentioned that. I think I'm still for it if Greg's up for it.
Yeah.
Okay, cool. So we were talking about just doing, so we still have to do the December meetup, and it'd be kind of a bummer to, cram that in between Christmas and New Year's. And we were talking about what to do. So I was thinking, well, what if we just did kind of a holiday stream in a week or two, just before Christmas, just before everybody leaves for the holidays. And yeah, I mean, if anybody has anything they want to showcase, a project that they're working on, maybe it can be a little bit more of a, I mean, the streams are always open invitation. If you ever have a showcase or library update, DM me, but maybe we could push for that a little bit more and let people know, really solicit for that. And, if you're proud of something that you built in Leptos or something that you're working on, or could be even, maybe you're just new and you just learned something and you want to share it because you're excited about it. That would be cool too. And we can just make it kind of a little bit of a hangout holiday party for the Leptos community. We don't have a date set for that, but we'll figure something out and we'll announce it in the Discord.
If you're on the lu.ma event, I'm sure it'll notify you. If you're on Discord, we'll make an event for it. I'll add that if there's anything you'd like me or Greg to showcase or demo or play with or whatever, please reach out and let us know. I think we've done so many 0.7 things at this point. Maybe people want more 0.7, but it's always good to hear from the community. So,
yeah, exactly.
Yeah.
I think pretty much every new feature I've shown off at some point over the last 6 months. It's just been getting everything together into the right shape. So go back and watch the old videos if you want to see more content about any of that stuff too.
Yeah, for sure.
Awesome.
Right,
well,
cool.
Thank you so much. Sleep well, if briefly, Luke, and have a nice morning, Ben. And we're really spanning the world here, but thank you everyone for being on here.
Thank you, everyone.
All right, take it easy.
All right. Bye.